Alright, so this is my problem 2 for the week 1 video explainers, and this problem involves a system called an anti-lock braking system, which basically it pulses a car's brakes just in order for to allow for just safer driving so that the car can be driven safely while the brakes are being applied. So in this problem, there are two situations, both dealing with the same initial velocity and the same mass of a car that is driving over a frozen lake. So in the first situation, the anti-lock braking is not applied, and the car travels for 10 seconds until it's at a stop while skidding. And for both scenarios, we were trying to find the impulse over the given period, and the first one having an anti-lock and the second scenario not having the anti-lock in place. So there was several ways that I was trying to go about solving this problem. However, I was struggling a little bit. So initially, I know that the force is equal to mass times acceleration, and the impulse can be calculated by multiplying the net force by the time interval, and by integrating the force equation with respect to time over the interval from the initial time to the final time, you can also get the impulse, which is the area under the curve. But that being said, I kind of struggled with formulating an equation. So what I ended up doing is, since I know that there was just a constant force being applied from the brake as opposed to a pulsating one in the other example, I calculated the mass, which is 2,000 kilograms of the car, times the acceleration needed to stop it, which would be a deceleration. And since acceleration is the change in velocity over the change in time, I know that the change in velocity was 30 meters per second, and the change in time was 10 seconds. So a deceleration of 3 meters per second squared was needed to stop the car. So in this case, 6,000 newtons required to stop it, giving an impulse of 60,000 newton seconds. And here's just a little diagram showing how the force of the brake is counteracting the velocity of the car. And in the second situation, I found some struggle with finding a way I can integrate the force time graph. The way I interpreted this problem was that because the brakes were pulsating 15 times a second, I figured that the delta t, at first I thought it would be 12 seconds, but then I realized that the impulse is acting 15 times every second, so that the delta t would be, 1 over 15 seconds, because even if you use the same methodology for this problem with the first one, and by not changing the delta t, you get the same answer. And here just had some more steps that I was trying to take, but I couldn't really find anything that worked. I knew, like I said, that the impulse is equal to the interval, the initial time to the final time. But that being said, I did not know where to go from there. And yeah, so those were kind of the tricky parts that I ran into. Just knowing how to interpret the 15 times a second for the anti-lock braking. And yeah, just relates back to what we're learning in class about not only just finding impulse and momentum, but how to connect the different parts of a system and understanding what you can solve for given what you have. So thank you.